this is about scheduling. So scheduling adds associated behaviors. So what are the things which will affect the scheduling? So we're going to see. So under this topic, we'll see three sections. First is controlling the pod scheduling behavior. So we're going to see a concept called pod placement. And then we'll see about limiting resource usage by an application. And then we'll finally see about scaling the application. So we'll start with the first section, which is about controlling the pod scheduling behavior. So in this first section, we are going to see introducing the OpenShift scheduler algorithm. So far we have seen whenever you deploy any application, the first thing happens with that application is that the scheduler is scheduling that application to the node, so worker node. So you can see that, for example, we have deployed one application here. When you describe the pod, OC describe pod, so here we deployed one application recently. OC project. I don't know. 7. So here we have deployed one application. The test app 2. So if we describe this pod, under that events you can see, first thing that happens with that is that the default scheduler successfully assigns this pod to the one of the nodes. So this is what the first thing happens with any pod. The scheduler is scheduling that to the node. And here we are going to see how this is working, like what is background things happening. So it's like it's not a random, so some algorithm is running at the background. So that is deciding so that this application is going to run on that worker node. So we are going to see that, and we are going to see how to influence it to some extent. So how we can decide where that application should run. So how to influence that. So the scheduler decides the application should run on this, and we can influence in some way to suit our requirement, so that the application deploys on the node which we want or which we intend to deploy, or intend that pod to run on that node. So we'll see that that's a concept of pod placement. Okay. And the scheduler is actually running on one of the default projects. You can just see OC get pods. Scheduler is on this project. OpenShift cube scheduler. So here this pod runs. Here you can see the scheduler pod is running on this project. For each master node, we have a scheduler. So master 1, master 2, master 3. So schedulers are there. So this scheduler pod is going to, so the request will go to this one, and it is going to decide where to place that application. So where to place that on the worker node. So we'll see about the algorithm. So scheduling algorithm. So scheduling takes place in 3 different steps. We'll go through the steps. The first step will be the filtering. So first step is node filtering. So what the scheduler will do, so we have different requirements. So like whenever you're deploying the application, all the applications are not same. Some application varies, like we have CPU requirement for an application, we have memory requirement, disk space, like so we have computational requirement for each application, which will vary according to the application nature. So depending on that, the scheduler, what it is going to do, it is going to get an input from one side. So it's going to get my input from my side, like whatever application I'm deploying. So I'm to say my requirement. Another side, it is going to check the availability, check the requirement, check the availability, or check what is the current availability in the worker node, so that this requirement is met by the worker node. Otherwise, if it is trying to schedule it without blindly, if that requirement is not met, so the application may not work or run properly on that worker node. So beforehand, the scheduler, what it's going to do is going to analyze the worker nodes. So how it is going to analyze, how it is going to fetch the data. So it is going to get the data from the etc. So it will get the fetch the data from etcd, and it's going to analyze the availability, the current running pods and current running pods over there, current space, what is the free space available, what is the CPU cycles available. So it's going to analyze all these things. Then it is going to match with our requirement. Then once the requirement is matched, then it's going to place that pod over there. So this is what it's going to do. First, it will filter the nodes. So if my CPU and memory requirement are this much, it's going to filter according to my condition. So whatever my condition, whatever the particular requirement for application is, it's going to filter the node. So whatever nodes which are not satisfying my requirement, so that will be filtered out. And next thing, the scheduler, what it will do is it's going to look for the artificial condition. The artificial condition is that maybe, for example, I want to reserve some nodes. So maybe I have 100 nodes which is online. So the 100 nodes are serving, the applications are running on that, and I want additional 50 nodes which I'll be using only at the time of the peak demand. So normally I'm not going to use this 50 nodes. The additional 50 nodes, I'm there, but additional 50 nodes stays online. But when there is a peak demand, I'll schedule the applications over there. So when there is no demand, normally it will be there staying online as an unscheduled node. And how to identify that? How to identify the reserve nodes? So I'm going to use a condition, like we can say the schedulable condition to be false, or you can set a condition. So like we state some condition using something called taint. So taint is something where you can place a condition on that node. So whether the application should be scheduled on that node or not scheduled on this node. Mostly we have different taint condition, and taint is one of the artificial means through which we can stop the scheduler from selecting this node. So normal scheduling. So I can stop the scheduler from selecting this node, so that during that scheduling algorithm, this node will be exempted from that scheduling process, or scheduling you can say scheduling algorithm. So it will be exempted from that. So it will not choose that itself. So it will manually isolate that. So whenever you want to make that node participate in the scheduling, then you release that condition. You remove that condition, automatically it will be included in the scheduling algorithm. So that is called a taint condition. So depending on the taint condition also, you are going to filter them. Taint condition we are artificially introducing on the worker node, so that some application will not be so that application is normally deployed on not deployed over there. So when there is a requirement, I release that taint so that this node will participate in the scheduling process. So like that, it is going to filter the nodes. The second stage after filtering the nodes, so there is something called prioritization. And prioritization, normally we are not going to see that. So for prioritization, we have to write something called affinity rules. So we have two kinds of rules, like affinity and anti-affinity rules. The affinity rules will give you a means to see where to place that part. So where you want to place that part. So you can write a rule depending on different conditions, like we may have a zones, we have the worker nodes in a distributed nature. So where I want to place this part. So for example, I can write a rule together, like affinity and anti-affinity rule. So I want to say whenever I create one pod in one location, same pod will be created in a like anti-affinity node, like the opposite node. Maybe some node maybe in south region and some node maybe in the north region. So whenever the pod created in the south region, similar pod should be created in the north region. So this is called affinity. So you can write the affinity rules, but we are not going to see about writing that rules. But when the algorithm process is going to run, it is going to take care of that affinity rules, and it is going to prioritize. So how you have written that affinity rules, based on that, it is going to prioritize the deployment. So that will be the second. Unfortunately, we are not able to see this in a practical way, but this is what happening inside the algorithm. So it's going to prioritize depending on the rules we are writing, affinity and anti-affinity rules. Also, you can write a part of that. You can do something like a pod placement. You can influence it using the labeling mechanism. So that we will see later on. And the last process is the best fit node, choosing the best fit node. So after filtering, after prioritization, so we may come up with a node, multiple nodes. Like when we're starting the algorithm, I may have 100 nodes. After filtering and prioritization, I may end up with like 25 nodes, which will be the best node to deploy that application. Among that 25 node, which node is best suited? So because that 25 nodes, I can have a mix match. Like I can have one node may have a lot of CPU things, like CPU resources may be available. Another node CPU resource, but it satisfies the condition. But one node may be superior to the other node. So depending on the availability of the hardware resources, or depending on the OS, some node may have RHEL OS, some may have core OS. So what this last process is going to do is it's going to just stamp the best fit node. Like it's going to give a weighted score for each node. So depending on different criteria, depending on the OS, availability of free space, like that. So it's going to give a weighted score. And the main purpose of this giving a weighted score is that I don't want to repeat this algorithm again in case of failure. For example, the node, for example, I have a node. That node goes down, and so during this algorithm, it has already calculated the next node where it can deploy the algorithm. So where it can deploy the pod. So during this calculation, so that it need not run this algorithm again from starting this, like filtering and prioritizing. So it already knows which node it has to take, because it's already prioritizing that, and it has given some scores for the node, and depending on the scores, it is going to place that pod. So if the nodes are having the same score, so the weighted scores are same, in that case, what it will do is it will load balance. First time it will deploy on one node. The next time the requirement cuts, it will not choose that node again. It will choose the node with the same scope. It will not choose the second node. It will do the load balancing. So this is what the last stage of the process, the best fit node. So it will just do its job depending on the highest score, the weightage score for each node. So this depends ultimately on the algorithm condition. So it is going to analyze and it is going to calculate the score. So this is what the pod scheduling algorithm is. So we're just understanding it theoretically. So this is what is happening at the background. And next is scheduling and topology. So scheduling is where we are going to schedule the application on our desired node, and topology is something in a hierarchical arrangement. The topology may be based on geographical location, or it may be based on zones. Like you can have some zones, high availability zones, or you may have some domains like failure domains, high availability domains, like that. You can have domains. You can have different. You can partition it different countries or different states, like that. So we can topologize an environment. We can we can form a skeleton of, or we can skeletalize our environment, because the nodes are always going to be distributed. So some nodes, so if I have there is a cluster, so there is a chance that the nodes will be distributed. So the worker nodes, some worker node may be in one zone and one region, some worker node may be in the different zones and different regions. So we are going to distribute it. Even if the nodes are in the same place, or if the nodes are in the same data center, we can still distribute it by the way of depending on the customer that nodes are serving. Maybe some nodes may be serving customers from UK, some nodes may be serving the customers from US, but the nodes are in the same data center. So we can topologize that depending on how it is serving the customers, or we can topologize depending on the environment. So some nodes may be dedicated for testing purpose, some node may be dedicated for production purpose, some node may be dedicated for non-production and quality analysis, like that. So we can distribute that node according to the environment. So what environment the node is particularly used for. So this is what the topology is. So topology can be for large data centers, such as cloud providers, to organize the into regions and zones, and it can be a geographical region, or it can be based on the availability, or based on the failure domains. So we can form a region and zones, so that we are able to hierarchically form a structure for our cluster. So this is what a topology, and scheduling is based on this topology. We are going to perform the scheduling. So we are going to do something called pod placement. So here is an example. So you can find that in the book. So here I have 8 nodes, and this is just a sample topology. So where these 8 nodes are distributed, like into different zones. So one zone, we have two different regions, and among that region we have two different zones. So if you take the node 8, so node 8 is located in zone US East 1B, and this zone in turn located in region US East 1, like that. So you can topologize the environment, but topology, forming the topology is it's up to us. So it's not like where they're geographically located. So geographical location may be different, but we can form the topology by itself. So after forming the topology, depending on the topology how you are formed, you are going to influence the scheduling. So we are going to see that later on in the something called pod placement. So we'll see the next topic, which is pod placement. So in the pod placement, we are going to see how you are going to influence the scheduling depending on the how you are labeling the environment. So here in our environment, so I have three different nodes. So only three nodes are there, which is acting as a worker as well as a master. So here I can have master 1, then I have to have master 2, then I have to have a master 3. So I have three nodes. So I can distribute these three nodes with different regions and zones. So here I'm going to just form a region. Here I'm going to say I'm going to place this. So we are going to topologize this environment. Since we have only limited nodes, we are going to form a very simple topology. So here these are the nodes which I have. So I'm generally referring this as a nodes. So this may refer to the worker nodes. The master nodes mostly will not going to topologize that, because master nodes are just for control function. So the worker nodes will be topologizing because it is the workhorse of the cluster. So where we are going to deploy the application. And here I'm going to form a region. So you can label it any way you want. Not that always you have to label it as a region zone. You can label it according to the environment. You can say environment is development, or environment is testing. So, or you can say different countries. So country, this is these nodes are in this countries, like that. Just you can form your own topology. So the way you are distributing your cluster. So here I have the master. So I want to place the master in the zone called Africa. So sorry, in the region called Africa. So this is just purely my convention. So I'm just for placing it in the region Africa. Doesn't mean that it is physically located there, but just for our convention to do some kind of pod placement or pod influencing. So I'm placing like that. So here I'm going to place the master 2 in the region called Asia, and here I'm going to place the master 3 again in the region called Africa. So two nodes are in the same region, and one node is in separate region. The purpose of doing this is to influence the pod scheduling, or you can say the pod placement. So I want to run the pod where I decide to run it. So this is what the main purpose of going for this. So in the pod scheduling, we have a lot of concepts. When you go to the Kubernetes, so you can find a lot of concepts with the pod scheduling. But here, just we are going to see one concept like pod placement. There are different concepts like pod evacuation. We have the concepts like pod cordoning. So different concepts are there with respect to the Kubernetes. So here we'll restrict our discussion to pod placement. So how I'm influencing the pod placement. If you want to know more about pod scheduling, so there are other topics like pod evacuation, pod cordoning, or writing the affinity rules, anti-affinity rules. So there are a lot of concepts over there. So if you want to refer to that, you can refer to the Kubernetes documentation, where you will find more about scheduling. But here just we are restricting to the one topic, like pod scheduling. So where pod placement. So I'm going to influence my scheduling. So depending on how I am forming the topology of my environment. So depending on that, I'm going to influence the scheduling of the application. So far we didn't influence anything. So far we are randomly it was choosing the node, so it was randomly choosing. Now I'm going to influence it. So that's what we are going to see. So apart from that, there are a lot of concepts are there. So I recommend you to refer to the Kubernetes to know more about scheduling things. There are a lot of scheduling things you can do with the scheduling. But here we restrict to this just this discussion. Okay. So if you know about pod cordoning or pod evacuation, or you can say the how to make the nodes taint conditions, how to set the taint conditions, and how to make the node to be unschedulable, or how to make the node schedulable. So there are a lot of concepts to the scheduling, but we are just mostly concentrating on this one. So if you want to understand the scheduling in a whole way, so you can refer to that documentation in the Kubernetes to more about scheduling. So here, first we'll see how we are going to form the topology. So topology, so we are going to form using the labels. So we are going to simply label the nodes, so that once you label it, after that, depending on the label you are mentioning on the node, so you can able to influence the scheduling. Okay. So here I have 3 nodes. If I do OC get nodes, you can find the nodes, the master 1, master 2, master 3, and you can see the labels on the node using this command OC get nodes -- show labels. So you can see the labels on the node. You can see the last section. These are the labels. So these labels are default labels for the purpose of managing these nodes, for calling this node for different functions. So you can see that the labels are comma separated, and label follows some hierarchy also. So it has some hierarchy. So depending on how you are calling that label. So like this, I'm going to label the node. So I'm going to label the node with the label as, for example, here I will be labeling the node master 1 as region Africa. So this is a user label which I'm going to place it. So the master I'm going to say region is Asia. So I'm going to label it the one way I want. So to label the node, for example, to label the master 1 with the label region Africa, so I'm going to use OC label command node. Then I'm going to label it master 1. So I'm going to say region equal to Africa. So I'm labeling it. Now the node is labeled. Now you can see show labels. It is going to show you the label which is here. Region is Africa. So this is kind of a clumsy thing to look into the labels. So to look the label which I am specifically interested in, instead of looking at all these things, so I want to specifically look at the label which I am interested in. So I'll just call this label identifier, or you can say label value, and check the label what it is got. So instead of looking all the labels, this is a clumsy way to look into it, because you have to search for the labels. Maybe there are chances that I may miss the label, because if there are more labels, there are chances that I may miss that label, and it's also very difficult to look into this among these labels. So to look the labels in an isolated way, I can use OC get nodes hyphen capital L. Here I can give the node name. So here I can give the label identifier, that value of that, the key of that label. So the key of that label is region. So here giving the key of that label. So once you are giving that, you can see now I can have the label identifier, or I can say the key of the label, which is region, and the value is shown in the below here. So the value is Africa. So the label is just there for only the master 1. So master 2, master 3, I didn't label it. So I'll be labeling that also. So master 1, master 2, and master 3. So I'll be labeling like this. So I'll be labeling the master 2 as Asia. So master 2 is Asia, and master 3 again is Africa. So if you see now the label, so now all 3 nodes are labeled. So for example, I want to change the label. So I want to change the label of this one. So I want to replace this with some different label. So I want to change the label from Africa to some other different label. So what I can do is I can run this same command. So whatever the labels you want to place it. So if I want to place the label to be something like Pacific, so I can just overwrite this information. So just you add this overwrite. So once you add this overwrite, it will replace that value. Okay. It will replace that value just to change the label. So this is the command to change the label. Other way, if I want to remove the label, so for example, I want to wash off the label from this node, so that this node is not having any label. So the overwrite is different from removing. So overwriting, I'm just replacing some value. So removing is something I'm going to wash off, so that this is clean without any label. So to do that, what I can do is I can use this command OC label. So node, for example, from master 3, I want to remove the label. So I can use the master 3. So here I'm going to mention the label value or label key or label identifier, and I'm going to give here a hyphen. So this hyphen, once you say the label identifier followed by a hyphen, what happens is whatever the value over here, this will be washed off, this will be removed. So if I do that, now you can see it's labeled, so that means that the label is removed. So if we now look into this, you will see that this label over here, the master3, is removed. So this command will replace the different value, and this command will entirely remove that value. So this is this we have to keep in mind when you're doing this labeling things. So to label it is very simple. So if you want to do any relabeling operation, or if you want to remove the label, you follow these steps. So let me again replace that label. So I just give the label again, so that now labels are, now all the nodes are labeled. So just by simply labeling, I'm not getting any benefit. So I have to utilize this. So how to utilize this? So I'm going to utilize this for the pod placement. So I'm going to do a pod placement. So depending on the label. So here what I'll do is, this is my topology of my environment. So inside the cluster, so let me say this is cluster which we are having. So inside the cluster, I do have these nodes. So I'm going to create a project. So in this project, I'm going to deploy application. So I'm going to deploy an application, and once you are deploying the application, that is a pod. So in the pod, for example, this pod you can name anything. So like any pod you can, like hello. So in the pod, initially you have some term called node selector. So in this node selector, I'm going to say that this condition, this key value. So I'm going to say the node key value that is matching the label of the particular node. I'm going to say the region is Africa. So when I say region is Africa, and this pod now is going to choose only this node, or either this node or this node. So it has a choice to choose anything between these two nodes, but it will not choose the this node, the Asia, that is master node 2, because the label is different over here, so it will not choose. And if you have other pod, so if the pod is not having any label, so for example we have other pod. So if I have other pod like something like welcome, so here the node selector, if it is none, then there is no node selector, the value is empty. So in that case, this pod is free to choose any 3 nodes. It can choose this, or it can choose this, or it can choose this. But if you mention the node selector, then it is bound to just go and get deployed only on that nodes which is matching the label of that node selector. If the node selector is nothing here, then it is free to choose any node. So by this way, we can influence the scheduling to some extent. This may be useful for in some cases, like I want to deploy some application on some nodes which is having high hardware resources, or I want to deploy some application on the nodes, or I can dedicate some application for the nodes for testing purpose, like that. So I can influence that. So I can label that node as testing nodes, so that the application I can go and change the node selector to be testing. So it will choose the node which is having the label testing, so that this gets only deployed on the testing node, so it doesn't impact the production node. So to some extent we can influence the scheduling. There are a lot of other ways to influence the scheduling here, but here we can do that using that. So there are other ways, like you can influence the scheduling with affinity and anti-affinity rules and all these things. So you can influence the scheduling in a better way. Here it's a very simplistic way we can influence the scheduling. And so when I do, like for example, when I change the condition, so for example the region now is Africa, so when I change the condition from what happens is all the nodes, all the pods will be terminated, and it will move from that node to the concerned node where you have changed it. So here one disadvantage that I'm going to face downtime because whatever the nodes are running, so pods are running, the pod will be terminated. So maybe I have scaled this application 5 times or 10 times, the 10 application which was running on the older node selector will be terminated, and it is going to be recreated in the newer nodes. So in that case, I'll be introducing a downtime. So you have to take care of this. So if you don't want to use introduce a downtime, there are other methods. There you can use something called pod evacuation or pod like where you can move the pod. In the pod evacuation, you are not going to kill the pod, or you're not going to terminate the pod. It is just moves from one node to the other node. That is a different concept. You can do that also. But here you have to remember you are introducing a downtime. That is a disadvantage of this one. But it will serve the purpose, because I'm moving from one node which is not at all useful there, so that I'm moving from one to other. So that downtime will not be an issue for me, because there is I don't have any usage by running that pods on that particular zone or region, so I don't have any use for that. Then I'm just moving that to the different one, so that it will be terminated from here, because it is not useful over there. It will terminate it from there, and it will be created in the newer zones or newer region where you want to move that pod. So we'll see that now. So we'll create a project. We'll see new project. So I'm going to say my demo 8, the new project I'm creating. So here I'm going to define some application. We'll see new app. I'm going to say name. This I'm going to use here hello. Again, I'm going to get it the image from the queue registry. So I'm going to get a image like hello OpenShift image. I'll be getting from the queue registry. I'll go to the repository, redact. So I'll be using this image to deploy the application. It's a very simple image. Just we want to see just the pod scheduling behavior. So I just use a very simple image that's going to run quickly. I'm going to use a Docker image. Copy that image over here. So let me deploy the application. And in the second window, just here, let me just keep a watch window. So the application is now running, and also the main important thing to, instead of just doing this, so I want to see where the pods are running. So that's very important. So now this is running on master 3. So instead of creating multiple application, I'll just scale this application. So see scale replicas. Let me scale it 5 times. So whenever you're scaling it, so you're actually modifying the deployment file. This is the command to scale it through the command line. So otherwise you have to edit the deployment file and go to the replicas and modify it. The same thing I'm just doing at the command line. OC scale. I'm scaling it 5 times. The replicas I'm mentioning. So I'm modifying actually the deployment file. The deployment file will be same. The name will be same as the application name, which here in our case it is hello. So I'm going to update it. So now it is scaled. If you look at now, you can see the applications are scaled, and now we can see the random nature of the application. So like the random deployment scheduling nature, I can see like it is doing that here. What it's doing is it's doing a load balancing. So you can see that one is on master 1, other is master 2, then master 3. So almost it is distributed in a equivalent way. So because we have only 3 nodes, so it is distributed in that the 5 pods are distributed in almost an equivalent way. So it's doing it like load balancing things. So the application here nothing is influenced. So it is just I'm going to leave that to the scheduler to decide where it should run. Now I want to influence it. So I want to run the application where I want to decide. So my deciding criteria may be depending on the node selector, which matches the labels of that particular node. For that reason only we have topologist in front. So this is the topology which I have formed. Depending on the topology, I'm going to do the pod placement. So here, if you look into the pod, if you just OC describe pod, so if you take any example pod here, hello, so any one of the pod from here. So let me take the first pod. So here, if you grep for the node selector, node hyphen selector, so you will be able to see that there is no node selector here. That's the reason why this pods were randomly getting deployed. So now I want to say that this application should run on the node, particular node where I decide to run. For example, I want to run on master 1 or master 3. So in that case, I can specify the region as Africa. So I'm going to go to that deployment file. I'm going to say the pod selector condition to be the label that matches the node. So here I'm going to say OC edit deployment. The deployment name will be hello. So here I'll read the deployment. I'll go to the spec section. Under the containers, we have the spec. We have two spec sections. One spec section is a main spec section. So another specification will be for the template. It will be for the pod. So you have the container specification. So under the container specification, I'll go down. I'll go to the last line. So you can add anywhere here. So not that it's you have to add it last. So here also you can add anywhere. You can add it. So for example, I can add it here. So here I'm going to add the node selector. N will be small, S will be caps. So this is a camel casing conversion they are following. So node selector. So below that I will mention the region. So region is here towards Africa. So that is the label of that node. So I'm mentioning the region. And once after saving this file, what you will observe that entire this 5 pods which was running here, it will be terminated, even though some pods are already running in that, for example, already running in the master 3. So that pod will also be terminated. So the scheduler, what it does is it will consider this as a new location. So whatever the order location is there, so it will just swipe off everything. So whether it is already the condition is meeting or not meeting, it will swipe off everything. Then it will newly create that on that node. So now you will see that this newly created 5 applications will be either in the master 1 or in the master 2. So you will not see this master 2 because now the condition I have influenced. So I have said to that that it should run on that particular node. So now I influenced that. So that is going to run on the particular node. So I come back here and I'm going to save this file, and you are going to immediately observe this. So I'll come back to this and I'm saving this file. So after saving this file, you will see that now everything is terminated. So previous ones are terminating and new pods are creating, and the created new pods, you can see it will be either in the master 1 or in the master 2. You will not see the master 2. So previously the master 2 was there, but now you can see only master 3 and master 1 because that is carrying this label. So that is matching this label. Now this pod is choosing only either the master 1 or master 3. And if I change the condition, so I want to see that I don't want my work is completed here. I want to shift these pods to some other nodes. So I want to serve that I want to serve the clients in different region. So I can do that. I can just shift this pod again to the different region. Just go to this node selector and mention that as the node selector region to be from Asia to Africa. So then automatically it will choose the master 2. Whatever the pods running on master 1 or master 3, that will be completely terminated, and all the pods will be created on master 2 because that is going to have that is matching with my node selection condition. So here if you examine any typical pod over here, you can see the node selection condition to be node selector will be region equal to Africa. So you can do describe pod. So here you can mention condition. You can just grep for the node selector. So here you can see that now the region is Africa. Now I want to influence it. So again, I want to go to the main configuration file, the deployment file. I'll change that. So I'll go to this OC edit deployment. I'll get back to the here in the node selector. So here I'm going to save from the region Africa to Asia. So I'm going to save this file. So once I save this file, you're going to observe that all these pods, all these 5 pods will be terminated, and you will see that new pods will be created. That will be created only on the master 2. So you will not see master 1 or master 3. So if I save this one file and if I go here, you can see now it is creating new containers. The older things are getting terminated, and you can see now everything is in master 2. So this is how you can influence the scheduling. And mostly we get troubleshooting things, like we see sometimes troubleshooting things in this case. Sometimes you see a pending error. In that pending state, you will see that if the nodes, for example, I am mentioning the node selection condition. With that node selection condition, I don't have any node, any node that is matching that label mentioned in the node selection condition. So in that case, the application will wait till the node with that label is going to come up. So it will wait because the condition is mentioned, so that will be given a priority. So it is going to always look for the node with that label. Unless and otherwise that node is going to come up, it will be in the pending state. So you will see sometimes you have to do this kind of a troubleshooting. So in that case, you have to go and either remove that node selection condition or label the node whatever the condition they have mentioned. So you have to do that things. So for example, if now I'm going to same deployment, I'm going to mention a label which is not there in my environment, which is not there with that label. I don't have any node in my cluster. So in that case, what happens is the pod will go into the pending state, and you will see one of the orchestration principle is that the previous pod, maybe one pod may be deleted. This pod still keeps on running because the newer pod is not coming up. So you will see that will be going in the pending state. As a rule of orchestration, you will see that unless and otherwise the new pods are running, the older pods will not be terminated. Maybe 1 or 2 will be terminated. Majorly it will be running. So almost 1 will be terminated, 1 or 2 will be terminated. Majorly you will see this is running, unless because it will be in the keep on the other, because the newer pod is in the pending state. So unless otherwise the newer pod is going to come up, the older pod will not be terminated completely. So you are going to observe that. So here we'll go and I'm going to give some random name here. So random selection name. So here the node selector condition, I'm going to say region something which is not available. So with this label there is no node available. I'm going to say this as Pacific. So I'm going to save this file. So once you save this file, you're going to observe this one. So if I just save this, you can see that now you can see it's trying to deploy it. So you can see the pending. So only one application got terminated and previous one is already running. So this is in pending state. This application is pending state. So why it is in the pending state? Because if you analyze the events of this pod, if you do OC describe pod, you mention the pod name, you analyze the event, you will see at the bottom, you can see the events. The scheduling had failed. You can see the failed scheduling, and you can see the reason. So the default scheduler gives me the reason that I have 3 nodes in my cluster totally, and out of these 3 nodes, nothing is available. 0/3 indicates are available, means 0 out of that means nothing is available, and 3 nodes didn't match the node selector. So I have 3 nodes. That 3 node itself didn't match the node selector, which I have mentioned in the application. That's the reason for failure of the scheduling. So we are identifying that. So you will face this kind of an issue. So here you can describe the pod and find the events. Also you can find that same thing on the project events also. You can just see OC get events at the project level. You can find that events over there. So here you'll see the on the top you're going to see here you can see the failed scheduling. So the same reason is showing for the different pods. So you will face some troubleshooting issues, something like this. When you see that the application pending state, when you go and analyze the logs, you find it's not matching the node selector. The reason will be the mismatch between the node label as well as the label mentioned in the that is a pod selector. So this may be the reason why it was in the pending state. Unless otherwise the node with that label is going to come up, it will be in the pending state. That will be given the priority. It is not going to run on any node because you have mentioned the node selector. That condition will take the priority. So it is always going to look for the node selector. If the node selector is not there, then it is free to choose the any node to deploy the application. But if you mention the node selector, it is always going to wait for that node. If the node is not there, it is not going to deploy. Even though I may have a space and all these things on other node, but since the node selection condition is there, it will take priority. It's going to keep on waiting for that node to come up, and so that the application will be getting deployed over there in that particular node. So yeah, with that we complete this session. So here we have seen about OpenShift scheduling algorithm. Then we have seen about scheduling and topology. Then we have seen about labeling nodes. Then the pod placement. Labeling the nodes, something is there called mission sets, labeling the mission sets. This we will not able to see in our lab environment because this mission sets mostly it will be in the cloud lab. So mission sets are something like a template. So you will create the worker node through the mission set. You will define the mission set, like you will say from which region you want to create that nodes, what is the size of that worker node, what is the hardware specification of that worker node. You can form a template. Through that template you can create a set of nodes. So 25 nodes will be from this region. Other mission set you can create that will be from the different region. The idea behind it that when you create the mission set, so in the cloud instances, in the mission set itself you can name it. So you no need to name the label after creating that. So in some case what you're doing is the nodes are already present. We are labeling it after the nodes are created. But in this case, even the node instance are getting coming up, that time itself it will already have that label. So if you mention that label in the mission set itself. The mission set is a template, the cloud level template through which you are going to create the worker node when you do the deployment of the OpenShift at the OpenShift cluster at the cloud level. So you will use this mission set. But here we are not able to see this concept because our lab is almost offline installed lab. So we're not able to see this concept, but there is a concept called mission set through which you will mention the label, the mission set template definition itself, so that whenever that data instances are going to come up, it uses that label to label the node. And we have seen about controlling the pod placement. So how to influence it, how to influence the deployment, how to mention the node selector in the deployment. Using that, how we can do the pod placement. And then you can see we have seen about scaling the number of replicas, scaling the number of pod replicas. So we have used the OC scale to that replicate that, or you can just scale the application. So far we have seen about using the deployment file. We edited the deployment file. There we go to the replicas and modify it, and we can do the same thing through the command line. So which is scaling the number of replicas. With that we complete the this section. So following this, there is a lab. In the lab you are going to do two things. One, you will deploy the application, then you will label the nodes, and then see that how depending on the label how the applications are scheduled. And other one you are going to do the lab is doing the troubleshooting. So here there will be a project. So project called the project name will be schedule pod-ts. This will be created once you run that lab setup command. This project will be created. If you go to that project and see the status of the pod, you will see that pod will be in the pending state. The reason will be there will be a node selector mismatch. You will identify the node selector mismatch, and you will see that out of 3 nodes nothing is available because it didn't match the node selector. So you will see this thing. You have to troubleshoot it. So you know how to troubleshoot it. Just edit that deployment, put the correct label, then you should see that application will be getting into the running state. With that, we'll finish this lab. So this is a very small lab. You can finish it now. So we'll start the next section by 12:25. So finish this lab. We'll start back the next section. So we'll go to the next section, which is limiting the resource usage by an application. So we'll start back by 12:25. So I think 15 minutes will be sufficient to finish the lab. So the lab is on page number 185.